My name's Heather, and I study viruses in marine mammals such as the dolphin. I'm here with my fellow scientists to discuss what is color. The first component of color to understand is wavelength. So we usually talk about wavelengths being long or short, and those distances between the peaks create either a long wavelength where this distance is greater than a short wavelength where the distance between that peak is shorter. When we're looking at the ocean waves, when we add energy, it creates the changes in the peaks. And this first, with a little bit of energy, is a long wavelength. And as we increase that energy, we're getting shorter wavelengths with more peaks in the water. This is also true for light. When we usually think of drawing a sun, we draw a sun with rays coming down. But since it's made up of light that has different wavelengths, a more accurate representation of the sun would have long, medium, and short wavelengths. Even some wavelengths that are so short we can't even perceive them with the human eye.
Hi, I'm Dr. Maggie, and I work on many types of animals, including Burmese pythons. As Heather just talked about, the light coming from the sun is made up of waves, and these waves are a type of energy. When these waves hit an object, wavelengths are reflected back and then viewed by our eyes as color. So when an object is red, the wavelengths bouncing off of this object are long, and we see this as red. And when an object is blue, the wavelengths reflecting off of this color are short, and then our eyes perceive that as blue. However, what happens when all of the wavelengths are reflected back? We perceive that as white. And when all of the wavelengths are not reflected or absorbed, we perceive that color as black. And because these wavelengths are a type of energy, when that energy is absorbed by this dog, that energy is turned into heat, and this animal then becomes warm. So on a bright sunny day, as today is, this dog would be much hotter than this white dog, because all of the energy is being reflected back, all of the wavelengths are being reflected back from his coat as opposed to being absorbed by hers.
Hello, I'm Dr. Megan, and I am a scientist who studies animals such as the Florida manatee. And as you've already learned, light is made up of waves of different wavelengths, and when that wavelength reflects off of surfaces, it is perceived by our eyes as color. But how are our eyes able to see these different colors? Well, we have cells in our eyes that are specifically able to send a signal to our brain whenever a certain wavelength touches those cells. These cells are known as cones, and these different cones respond to different wavelengths. So if there is a short wavelength that hits these cones, it'll send a signal to the brain that this is a blue color. If there's a medium wavelength, it will send a signal to the brain that this is green. Or if it's a long wavelength, it will send a signal to the brain that this is red. Now, we're able to see these different colors depending on what light is reflected back. But as you know, we're able to see more than just these three colors. And how that's possible is that our brain takes the information that each of these cones transmits to the brain depending on the wavelength, and the brain turns that into a color. So if it's only red, if only red wavelengths are reflected back, your brain's going to say that's red. But if it's a mixture of different colors, your brain's going to say it's a different color. And those different colors are what we find in the whole rainbow. Now, we don't completely understand as scientists exactly how our brain is doing this. We understand some of it, but not all of it. And so if you are interested in science, this may be something that you can study when you get older as an adult and figure out exactly how our brains are turning information from three different cones into all of the colors of the rainbow in our brain.
Hi, I'm Dr. Gretchen, and I'm a veterinarian, and I study horse health. So as Megan said earlier, most people have 3 cone types and can see all the colors of the visible spectrum. However, some people only have 2 cones and can see a limited amount of color. But they're not alone. Most of the animals that we know and love only have 2 cones as well and can see a limited amount of color. Like this bunny here, she can only see colors of blue and of green. Dogs and cats can see in shades of blue and yellow. That's why Blaze loves her yellow tennis balls so much. Over here we have an example of what an image would look like seen from the eyes of a human versus the eyes of a dog. On the left-hand side, there's the image of what a person will see. On the right-hand side, it's what a dog would see. You notice that all the colors of red have dropped out of the picture. Some animals have even more cones and can see colors that we can't see. Like the blue morpho butterfly has 5 cones and can see more colors. And the even cooler animal is the mantis shrimp, which has 16 cones and can see probably colors that we can't even imagine.
And that's what color is. Thanks for joining us.